giggling. Okay, so we did this before. We talked about the area under the curve. The last time we looked at this, the parabola was the wrong way around. Okay, I don't know. Okay. All right, so the integral is that area that's shaded here with those rectangles. We looked at that a little bit before, but we hadn't really done anything with it. So here's your fundamental theorem of calculus part 2 is, the deal is that we're going to give you boundaries. So in this one, we went from A to B. That's supposed to be around A. So lower limit goes on the bottom. So this is your lower limit, this is your left, this is your lower number, and the upper limit goes on the top. They're in order. You have to antiderive this. So once you get the antiderivative, you're going to substitute in the upper limit into the original formula and subtract the lower limit once it's been inserted into the original formula, and just subtract them. And that gives you the area under the curve. Okay? So two main steps. We got to find the antiderivative. Step 1, find the antiderivative. You're going to place it in brackets. So if it's a capital F, that means antiderivatives. And you're going to have plus C. And I'm going to show you why it actually doesn't matter. And then your lower limit and your upper limit. This is really important. You have to know that notation. So that notation is critical in making sure you've done it correctly. Now, this whole thing under here, it looks like a bunch of gobbledygook, but it's not really. So what I've said, let's do a quick one off to the side here. So let's say I take the integral of 1 to 3, and we're going to have the derivative, okay, of dx there. All right, so step 1 would be to antiderive x squared. So if we do the antiderivative of that, that's going to be x cubed over 3 plus c. Right? You guys agree with me? No? Everybody's left the meeting? We're all good? Okay. All right. So the thing is that this c doesn't really matter. So we start with our upper limit, and our upper limit I said was 3. So 3 cubed divided by 3 plus c, subtract 1 cubed divided by 3 plus c. So what happens is we've got 3 cubed, which is 27. 27 divided by 3 is 9. So 9 plus c minus a third plus c. And that negative gets distributed throughout the bracket. So here and here. So 9 plus c minus a third minus c. So always the c's are going to end up canceling it out. So even though they're still there, the math behind it is they end up canceling out. So I don't have to show that step every time. So my answer would be 8 and 2/3. So the area under that curve would be 8 and 2/3. So again, the c's, although they are still there, they're still present. We usually don't show them because we all know that they cancel out. Okay, so let's do this one. So we have the 5. So the first thing we're going to do is we're going to antiderive 5. So what's the antiderivative of 5? Anybody?
5x.
5x. So antiderivative, so we're going to write down 5x, square bracket, and then we're going to put, there's a lot of giggling, lower limit on the bottom, upper limit on top. Okay, so this is the correct notation. When it's in the square brackets, we know that it is the antiderivative. So now that's step one. Step two is where we put it into the formula. So we're going to have upper first. So 5 times 7. Ooh, things are not going so well here. Subtract 5 times 5. So 35 minus 25. And so the area under the curve is 10. Everybody good with that?
Yeah.
Okay. Okay, I just have to reorientate. I'm going to see if it works a little bit better.
Turn your mic on. The one next to the 7. This isn't toxic Google Meet.
I love it. Toxic Google Meet, just what we needed.
No, we got it.
Okay, so
It's a 7.
he was sleeping.
Missy, I can go back for Tom.
Okay.
There you go, Thomas. You're welcome.
Yeah, you're being mean to me. So rude.
Yeah.
It's 5 brackets.
It's 5 brackets 7. That's a 7.
What is that?
Turn on your microphone as well. You can read your head.
Yeah, I'm away from my computer, so I can't see it.
God.
Okay, I'm moving on. So step one is to always antiderive it. And again, I'm not putting my c because the c, although it should be there, it gets canceled out. So I don't put my c in this when we're evaluating the integral. For the first time, we've got numbers above and below. So when I'm evaluating the area under the curve over a certain domain, I don't have to put my c. So antiderive this, so going back to the original, that'll be x 4 over 4, and then we're going to have plus 3x cubed over 3. Oh, that's supposed to be a minus x squared over 2. Square brackets has to be square brackets. -1 on the bottom, +2 on top. So now that's step one. Step one is always to find the antiderivative, put it in those square brackets. And so now the next step is going to be evaluate f of 2 minus f of -1. So we're just substituting 2 into the equation first, evaluating that, and then we're going to substitute in -1, and we're going to evaluate that and subtract them. So I'm going to have 2 to the exponent 4 divided by 4 plus 3, 2 cubed divided by 3, that's cubed, minus 2 squared over 2. Now notice my brackets have changed to round because I'm evaluating. I'm writing way too big because I'm running out of room. So I've got -1 to the exponent 4 divided by 4 plus 3 times -1 cubed over 3 minus -1 squared over 2. And that's going to give me, this will evaluate out to 10, subtract a -5/4, and so subtract, and so that's going to give me a positive number, so that's going to be 45 over 4. So really just remembering to antiderive it and then always to do the upper limit, subtract the lower limit. That's really the basic steps for this one. For the next example, I think that the wisest thing to do would be to make this a rational negative exponent before I antiderive it. So instead of writing it like that, I'm going to write my integral again, saying, hey, this is still the derivative. So this would be 2 times x to the exponent negative 3 over 2. So I haven't antiderived it yet. I just put it in a nicer form so that I can antiderive it better. All right, so square bracket. We're going to antiderive this, so that means I have to add 1 to the top. So I'm going to have 2x to the negative 1/2 divided by, and whatever my exponent is going to be my denominator. And then we put the boundaries on it, 1 and 4. So this looks a little bit messy. I'm going to tighten this up just a little bit. So this is, I'm going to multiply by the reciprocal of that, so I'm going to get negative 4x to the negative 1/2, lower boundary of 1, upper boundary of 4. So the next thing I would do would be evaluate f of 4 minus f, a positive 1 this time. Keep in mind, capital F's indicate that we are substituting it into the antiderivative or the original. So we're going to have negative 4 times 4 to the negative 1/2, subtract, I'm going to use round brackets here, negative 4 positive 1 to the negative 1/2. And if I evaluate that, this is going to give me a negative 2. This will give me a positive 4. Sorry, it'll be a subtract, subtract. So my answer will be 2. So the area under the curve is 2. Anything terrible? You guys good with that?
Yeah.
Perfect. Thank you. It's very weird. It's very weird, but I'm glad I can hear your voices. Makes me happy. Okay, so this one's a little bit different. We're going to do it integration-wise, and you'll see why it's a little bit different. Every area we've had so far has been a positive area. So all of us are okay with that. It looks normal. Things are tickety-boo. But with this one, we won't get the same thing. So when we antiderive this one, it's going to be negative x squared divided by 2. I guess I should have extended my brackets. 0 and 3. So we're going to have that negative stays outside, so it's the 3 squared divided by 2 minus negative 0 squared. That's weird, divided by 2. So we are going to have a negative 4.5 minus 0. So that's going to give me an area of negative 4.5. So that's weird. The first time we're seeing a negative area. But I'll show you, this one works out nicely because it's a linear function. So I'm going to show it to you. So what we're going to do is we're going to graph the derivative. So we're going to graph the y equals negative x. So if we do that, so these are 1s. So that would be 2, that would be 3. So at 0, 0, that's pretty standard. This one would be 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4. So we get that linear function. Everybody okay with that? Now my boundary went from where? It went from 0 to 3. So if I were to mark that off, I'm going, my boundary is from 0 to 3. So I'm just going to make a triangle here, and this would be the area under the curve. Because we're looking at the bounded by the function and the x-axis. So that's the area of that one. And so mathematically, if we do this, this is going to have a base of 3. This is going to have a height of 3. And for area of a triangle, 3 times 3 divided by 2, which is 9 divided by 2, which is 4.5. And you're like, but our answer was negative 4.5. So here's the thing, any areas below the x-axis are considered negative areas. So areas below the x-axis are considered negative. Okay, so not hard, just like velocity, it's got direction. Now all of a sudden our area kind of has some sort of direction as well. Okay, so we're going to look at this one, and we're going to sketch the function, and then we're going to evaluate the area. So for this last one, I'm going to sketch this function here. So I cross it 2, my slope is 1, so up 1, I assume these are 1s. Over 1, up 1, over 1, and I can go down. So this will be my function. I messed up on my last point there. Luckily, I have an eraser. And over here. Alright, so that's my function, f of x equals x plus 2. Okay, so it's bounding me by, the boundary on this one is -1 all the way to 2, so right to here. So this area, the blue section, is what I'm going to try to find. So obviously not a triangle, obviously not a rectangle, but I can bust it into composite shapes. So I can take the area of this rectangle, so I'll call that area 1, and I'll call this area 2. So once I get those two, I can just add them together. So this one has 1 unit, 2 unit, 3 units, so it has a base of 3, and it has a height of 1. So the area of section 1 is 3. The area of section 2, now that one's a triangle, so it has a base of 3 still, and it has a height of 1, 2, 3, so we know that that area is going to be 4.5. Now all of this is above the x-axis. All of this is above the x-axis, so that's going to be a positive. So the total area is going to be 7.5. Okay, so that's doing it graphically. The idea is to just link these two things together. These are going to get more complicated, so obviously I'm not going to have you graph like cubic and quartic functions. We just do the integral of them. Okay, so then it says evaluate this to see if it matches that answer. So we're going to do it algebraically. All right, so just going to grab my sheet because I've lost it. So the integral of -1 to 2. Hey Kendra, did you watch the first video?
Yes, I did.
You know we were talking about you?
Yeah. About the integrals and when you're like, oh, I think it looks like a music thing, but I can't correct it because she's not here.
She's not here because I sent it to the wrong email address. Meanwhile, I just thought you were just skipping class.
Yeah.
And to derive this, so -1, +2. What was that? Sorry?
Oh, nothing.
Nothing. We're yelling at Thomas?
Maybe.
Maybe. That's okay. You're gonna do what you gotta do. So step 1 is now to derive it. Step 2 is do the math. So I'm gonna have 2 squared divided by 2 plus 2 times 2 subtract -1 squared divided by 2 plus 2 times -1. So I'm going to get 6 on this side, minus a -1.5. And so my area is going to be 7.5, which is exactly what we found when we did the graphically. The trick with the graphically one is that you have to graph the derivative. That's going to be the trick with that. But really, that's it. That's all. That's the entire lesson, and we did it in 21 minutes. That's going to be a new record for us.